Hello guys, and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class we are still going to talk about mathematical aspect of quantum computing, and we are still staying in linear algebra. So what we are going to cover today will be three basic notions that are pretty important in linear algebra in general and in quantum computing as well. So basically what we will cover today will be spans, bases, and finally dimensions of space vectors. So basically my goal today is not to make all the mathematical demonstrations of each of those elements, but simply to introduce you the most simplified way to those notions because they're a little bit complicated. So let's start. All right, so the first thing that we are going to talk about will be a span. So basically, what exactly is a span? So a span of a set of vectors, we can see it simply as the set of all linear combinations that those vectors have. So for example, let's say we have two numbers that would be a and b, for example, and that we have two vectors. So those vectors will be vector 1 and vector 2. So this would mean that the span of vector 1 and vector 2 is the set of all vectors of the equation that will be our number 1, so a multiplied by vector 1 plus b, which is our second number, multiplied by vector 2 for some scalars a and b. Now, what is the difference between the span and a linear combination? So yes, there is a pretty major difference between those two elements. So what we need to understand in this case is that a linear combination will simply be a sum of scalars multiplies, sum of the scalars, multiplies of elements that are in one basic set. The span, it's a bit different, is a bit different. So since the span of a basis set is the full list of all linear combinations that can be created from the element of that basis set multiplied by a set of scalars. So now what we need to understand is what exactly is a basis. So in linear algebra, basically, a basis, how we can see a basis, we can see a basis for a vector space V is a linearly independent set that can spans V. So in other words, if V is given as the span of some sets of vectors, then a basis can be obtained by simply throwing out redundant vectors. So this would be for a basis. Finally, the last concept that we need to understand today, or that I wanted to present you today, will be the dimension, and it's really important to not to talk about, but to understand the difference between the dimension of a space vector and the dimension of a matrix. So basically, for those of you who understand who did the basic linear algebra, the dimension of a matrix is simply the number of columns versus the number of rows. So basically, it will simply give us the dimension. So how exactly our matrix will look like. So basically, for the dimension part, let's say we have a vector v, or a space vector v. This space vector is spanned by a finite set, so then v is said to be finite dimensional, and in this case, the dimension of v will be the number of vectors in a basis for v. Now let's say we have a vector space 0. So basically, in this case, it's going to be 0. Then the dimension will be defined as 0 because our vector space will be 0 in this case. So it will look, it's going to be 0. And finally, if our vector space, this is for the last type of vector space that we can have, is not spawned by a finite set, then it is called an infinite dimensional vector space. So basically, there are three types. So it could be finite, it could be defined as 0, and finally, it could be an infinite dimensional vector space. So those were the three elements that I wanted to talk about in this class. In my opinion, they're pretty important. As I said, I didn't want to make all the mathematical demonstrations about each of those elements because once again, it's a bit complicated to understand and even to teach, well, in words, and try to put it as easy as possible. But this is what you guys need to understand from those terminologies. So that's it for this class, guys, and see you all in our next class.